Good evening, everyone. So we're going to do another video here. In the previous videos, we looked at building a C++ based Lambda function using the SDK and the C++ runtime. And we kind of evaluated how to do it locally on your PC or using the Cloud9 environment. It's a bit of a debate there about which is the better way to do it. After playing it with for a little while, I think that actually the answer is to use both. So what we did was we put together this new repo. And the other thing that's different here after talking to some people is the C++, like I say, that runtime environment, it feels like it's not very mature right now. And one other option is to actually use the Python handler or one of the other runtimes, but the Python one that's built in. And they just have that Python script, that handler, call the C++ executable by uploading it as a zip package. And that's really nice. You kind of have the best of both worlds. It's a little bit slicker. So we'll just go through here how to kind of do that. And again, this is the repo that we're going to walk through. And by doing that, what you'll be able to do is do a lot of your lower level unit testing into your own development environment that you have. You don't have to use the Cloud9 sort of IDE, which is okay, but it's certainly not as powerful as something like CLine or many of the other ones where you can go in, you can develop either in the Python bit or in the C++. For instance, myself, I use the Google Test Suite, so you can have that full integration, do all your unit testing, that test-driven design. And then when you have the lower level functions, you can then start to worry about deploying into the AWS environment and the Cloud9 integration. And the other thing I've kind of done here, which I think is a good idea, is kind of isolate the AWS pieces. So for instance, I have an S3 namespace, which does reading a YAML file from an S3 bucket. So if you isolate everything into those types of functions, then you can test all the other functionality of your C++ code. And I assume if you're going to C++, it's because you're looking to do something a little heavier, a little numeric, something that's not standard that you could use out of the box with a Python package. So you're kind of, again, it's a fairly low level thing. Don't think that's something that's going to be directly integrated into AWS, probably more at a higher level. And that higher level then you can do at a with something like the Python SDK. So previously we had some other environments. Instead of kind of reusing it, that's the nice thing as well, is that after you have that, all your unit tests done, you can spin up a very clean environment. You have complete control over what you're using. So I'm just going to spin one up here. And one of the other nice things that we can do is, I think I might already have a demo done, is control the type of instance size. So the last time we did this, we did it with a micro. However, when you start building the SDK, in particular the S3 package, previously we just did the core. It takes more memory just during compile time. So I think it's 4 gigs of memory, so RAM. So you can't get that with the T2 micro. So what I actually grabbed was the T2 medium, which was fine. So with that, you can do your initial build. And then when you're finished with the build, you can just go in and change your instance type and go back to a T2 micro. So to do that, you just simply close your Cloud9 web interface, go into the instance, stop it, change the instance type, start it back up, and you can go back in again. It's pretty simple to do that. So with that, we'll just go down, grab the VPC that we created previously, and we will spin that up. So while that is running, I'm just going to hit pause, and we'll come back when it's finished. Okay, so the Cloud9 environment has spun up, and that's what we wanted. And so we have to go through these first few steps. And this is why I say it's kind of, I wish that AWS actually had a development environment for C++ where all these things were already installed, but they don't. So I'm just going to copy all of this stuff, just drop it in here, hit paste. And again, I'm going to hit pause while it goes through this. This will take about 15 minutes. So, get a copy and come back. Okay, all of the dependencies were installed. And actually, my video capture crashed during the second piece, but I just went in and grabbed all of these commands and just popped them into the terminal here to run and build the AWS SDK. And so you can see this is actually after the SDK was fully built and installed. So we just go up, you can see install, make, and then that big command. So now that we have the SDK and the dependencies all built up, we can actually go in and build the Lambda function itself. So I'm just again going to copy all of this and drop it in and paste. One of the things you'll notice when it's going in here is that it's actually grabbing both this repo, which is this one here, but it's also going in and grabbing a second repo, putting in this third-party directory, which is the YAML C++ package. that just allows it to parse a YAML file in C++ very easily. It's also just kind of showing again how you can go in and grab other packages and build it all up. And then of course we went in and just did the final CMake and then make. The make didn't hit the enter key. So that's just building. It has to go through and actually build the full YAML C++ package, which is the longest part, and then this very quick build on the deployment. So while that's going, I'll actually, instead of pausing, jump in to show in the compile. We noticed here I have this Cloud9 on and off, and this is just where I have a toggle in the CMake file that allows me to check or switch between going locally, which I want my full Google test integration to be able to do all my unit testing. And then if I'm on Cloud9 and I want to have the full SDK installed. So it's just one way you can kind of have it where you have the best of both worlds. Okay, and that's all built. And so we have the executable built, and we are ready now to get into building the roles. So now we have to go into making the role. This is of course a role for the Lambda function, so it can execute and access both the CloudWatch to make the into the logs, write to the logs, and also into the S3 bucket, because we're going to try to get it to read from the S3 bucket. So normally what you would do, you can either do this through console, obviously. I like to try to do it through the CLI. However, when I do it through CLI, I get an error, which I'll show you right now. And so all you have to do is take this information, drop it into a file here locally. You know, I said trust policy JSON, so we have it here, and then run this command to create. I guess before we do that, just jump over here, just making sure that it does not exist. Okay, it doesn't exist because I've done it several times. So let's just copy this in and go to run. Or through the Cloud9 environment, I do get this invalid token. So because we're using the temporarily managed credentials, you can't do a lot of these IAM tasks. So what I'm going to do, and which makes a lot of sense because this might be a shared environment. So you know, doing the AWS config and everything, it's a bit iffy. So I'll do it here instead, and just to show you, this is the exact same policy. I am going to shrink this because when it creates the role, it spits my account number and everything on the screen, so I don't want to do that. So let's just paste it in. Boom, there we go. You had to hit Q, by the way, to get out of there. And so now we can see it's created the roles. However, there is no permissions or anything attached. So let's go back in here, and we're going to attach, as I mentioned, these two policies. So I'm just going to grab both of these lines, go back again, and it still won't be able to do this through Cloud9, so I'm going to do it here. So paste these two lines, boom. Now we go into IAM, we do a refresh. And we can see that we have these two roles in there. So now we can do everything that we need to run the Lambda function. And so the next set we're going to do is to zip and deploy the Lambda function. Okay, so now that we're ready to go, you'll notice here, because we're not installing the C++ runtime, but we do need the SDK. There's a number of these dynamically linked libraries, and these are dynamically linked by the SDK itself. I looked through, there's a lot of discussion. I can't really find a better way to do it besides including these in the package. They're fairly small, so it's not the biggest deal in the world. But again, the whole C++ environment is not quite as polished as the Python one. So to do that, let's just copy these, and you can see what I'm doing here. I'll just walk through as these commands are running. Oops. Is I'm going in here and I'm making a new folder called package, and then I'm copying in the handler itself, which is just a Python bit, and then the executable that we just compiled, and those link files, and just creating a zip package. So once I have that, I'm then going to go push that into AWS, the Lambda function as a package itself. Now you'll notice in here, it's your account ID. So because of that, I'm actually going to do it off screen and come back, just so I don't have my account number going everywhere. And then we'll have the package deployed to AWS. Actually, before I go and do that, I am going to go in and just make sure that we don't have it. And sure enough, there's no Lambda function in here that we're going to call. These are the ones that we did previously on Cloud9 when we were using the full C++ runtime environment. That's why it's called custom runtime. And you notice the sauce is 13. This is when we did it with not attaching any of the packages. And this is the full package that we had in here. So let's just go back. And like I said, I'm going to actually hit pause here when I do this command so I don't flash my account everywhere. Okay, so I did that. I also just cleared the screen. One of the things I did notice when I was running it though, in here it says memory size of 80. There's actually a min size of 128. So I had to change that to 128. I'll do that into the repo after the fact. But now you can see when we go in and we do a refresh, we have our new Lambda function put in here. Now, one thing you will notice when you go in is that there's no trigger. So the next thing we want to do is put a trigger in here. So as soon as we put something into an S3 bucket, it automatically goes and processes it. The other thing you can kind of see that's nice in here is that here's the package, right? It deployed, unpacked it, and all set it. So you can see we have the Lambda function, which is using the Python Lambda handler, which is pretty standard. And then it calls its exe. Obviously, right now the exe is not doing much. It is going and reading from an S3 bucket and pulling it, reading the YAML file, and just writing out a command. Very, very simple, but you can imagine it can do something a lot more sophisticated than that. So now that we have the package. Oh, one thing here, I just put this command in. A lot of times you might be going in as you're debugging, oh shoot, I got to go back, recompile. So this is just the update function. So once it's made, you can just go and run this and it can update the function over and over again. So the next thing we're going to do is actually create that S3 trigger. Okay, so to get started, you have to create a bucket. Obviously, you could do this through the just through console, pretty straightforward, or I'm just going to go and run it here. You will obviously have to create it with a different bucket names than mine. They are globally unique, so if you just use mine, you're not going to get very far. I'm going to call mine boom. So if we go into S3 now, and I do a refresh, you can see I've got a new Lambda C++ test bucket in there. And next thing we're going to do now is put this policy so that it can go and S3 has permission to invoke a Lambda function. So right off the bat, you're not going to be able to do this. Now, unfortunately, this particular command has your account ID, and then of course you'll have to update your bucket. So I'm just going to hit pause now. I'm going to just run this command in the console and hit clear afterwards. Okay, so that ran through. So now the S3 bucket has permissions. The next thing we're going to do is actually put the trigger on there, right? So this is what we call an event configuration on the S3 bucket. We do need to have this file, so let's just go and create a file out here. Again, all these things you could be doing through the console, but I think it's a lot nicer to have it through the CLI. You have a better understanding of exactly what's happening behind the scenes. So it's just, you don't have to call it this, obviously, you can call it whatever you want. The other thing that you're going to have to do here is put your Lambda ARN in. And unfortunately, your Lambda ARN also has your the account number. So I'm just going to hit pause here, put the information and close the file. Okay, so I just updated that your Lambda ARN with my full ARN, which includes the account number, unfortunately. And with that, we just have to go down now and run this S3 API command right here. You have to update, of course, with your bucket name. So I'm just going to do that off screen, put my bucket name in there. Oops. And I have to CD back where that file was just created, which was back in the environment directory. So just boom, and like I said, my Lambda, my bucket name's here, your bucket name will be different. Boom, and so now when we go back to the trigger, let's do an update. Of course, that flashes my. Now we can see we have the S3 trigger here, which is great. So the trigger is set up to run as soon as a file gets uploaded into the bucket. So with that, let's go and try it. I'm actually just going to jump back in here. So let's see, did I create one inside? Sdk. Yes, I made one in here. It's really simple. It just says greeting. Hey, they're good looking. All it's going in is reading the YAML file, pulling out the, looking for the key greeting and just printing back the value, which is, hey, they're good looking. So let's go in here. Okay, so that's the test.yaml. And let's just throw it up to the bucket. And of course, the bucket has to be the actual bucket name, right? Which is going to be a little different for you. So now if we go back to S3 And we'll go into this one. We can see, boom, this just happened just then. That test YAML file got uploaded to the bucket. The Lambda function should be invoked, and then it just writes to the logs. So now when we look into the logs here, is there a new log? Okay, so this is the new log group that was created, and this has the one log stream, and this is the event that just occurred. Let's open up a little bit so we can see a little better. One of the things I do when I'm writing this, it's just good practice, I think. When you go back to the main, you can see, or I'm sorry, not in the main, in the Lambda function itself, is I print the event. I think this is just nice so you can kind of see exactly what came in. So it just gives you the full event. It sees what you can actually pull out. So there's a lot of information that comes in with that event handler. And then there's the command that I ran. You can see I'm actually calling the C++ file, that little executable, and it printed back, hey, they're good looking. So it read the YAML file properly from S3, parsed it in C++, and that executable, and then just report it. You obviously could do something a lot more complicated than that, but there you go, pretty much end to end. I think this is a much nicer interface than doing the C++ runtime. You kind of keep the simple stuff, high level stuff in the Python runtime, and then you can kind of build your much heavier lift things, which is why you're doing C++. If you're doing something simple, of course, you just keep it all in Python. But if you had something heavy, you could have it in C++, do your development locally in the unit tests, and then deploy it and keep, of course, your AWS specific interface separate from the actual heavy lift. That way you can test independently in a different environment and bring them all together into Cloud9 and do your final testing. So with that, hopefully you enjoy this and learn something new. Thanks. Have a good night.